Hi, I'm Manoj Kamalanathan. I'm a senior research scientist at Bigelow Laboratory for Ocean Science. Our dependency on fossil fuel is really affecting our oceans. It's affecting the life and diversity in our oceans. So we need to reduce our dependency on fossil fuel. To do that, we need to find alternatives. Now there are alternatives like solar and wind. They are good, but they're just not enough. We propose a system, an algal system, which will continuously produce hydrogen. This algal system will be integrated into a bioreactor. Now, this bioreactor will be custom built, and it will be scalable, and it will be cost effective. It will be scalable in a way that you can use it in your home, like an espresso machine, or a business owner can use it in their industry. So hydrogen production from algae was first discovered in the 1960s. You might wonder why we are not using algae to produce hydrogen then. That's because there's not enough research, and most of the research that has been done has only focused on one species of algae, but there are thousands of species of algae there. And we propose to tap into that diversity to find the best candidate that can produce a lot of hydrogen. Then we propose to use physio, biochemical, and genetic means to make them produce even more hydrogen. My colleague John Burns will tell you how exactly we're going to do that.
Hi, I'm John Burns, a senior research scientist at Bigelow Laboratory for Ocean Sciences. Algae have some of the most versatile metabolisms of any organism on Earth. They look like little green plants, so they photosynthesize and they make sugars just like the trees and grasses that we're used to. But they can also slip into fermentation, where they produce things like ethanol or hydrogen, kind of like yeasts like the ones that we use to make beer. But algae can do it using sunlight for energy, so that's where we really have potential to tap into their abilities. We are working on two processes in algae. One, we want to push them into producing hydrogen. So away from their normal photosynthesis to produce sugars, we want to use physical means to push them into hydrogen production. And secondly, we want to manipulate their genetics so that we can enhance their ability to produce hydrogen. And we're going to couple that with the bioreactors to make this into a household product for continuous production of hydrogen and electricity.